Okay, so thank you for rejoining. Now we will quickly take up the questions. These questions are just to make sure that you can be able to solve the other assignment problems. So this is just for the practice purpose. So now the first question says that the following reaction that we can see, here is the substrate I have just explained. So more or less the questions would be covering all the examples which are coming from your slides or whatever we have understood. So this part, it is giving you this product. So this is your substrate and this is your product. Now it has been asked that this reaction is named as what? Is it ring opening metathesis? Is it ring closing metathesis? Is it ring opening, ring closing, or it is ring opening metathesis polymerization? Okay, we know that this 7-membered ring has been opened to form the 6-membered ring. For sure, it's a ring opening, but also there has been some ring closing also. That's why we could see that 5-membered ring is here, and then yeah, answer C is correct because we just have seen this example. If I'll just open the ring opening, just a second, I'll show you the. Yes, we have taken this example. So here, this one. So the way we have taken this example, yeah, it's the exactly same example where we have already explained that firstly, this particular, because the catalyst that has been used, this is your metal carbene catalyst, and it is nothing but the Grubb's first generation catalyst. And in presence of this, it is undergoing ring opening of the strained norbornene system, and then that would combine with your alkene. First, it will open, and this will then combine with this particular alkene to give you the desired product, which we have already seen, and it would give you a 6-membered and 5-membered ring, where it has not asked for the product, which product has already been given. But the answer is your ring opening and ring closing metathesis reaction. So the answer was right, which you have given. We can go to your next example. Okay. So here we have another example where again, if you'll see, it's another type of Grubbs catalyst. It's a second generation. These kind of Grubbs catalyst has also been explained already in the previous lectures. If you have missed the sessions, then please go back and check them. Okay, now if you will see it carefully, we have one alkene over here, another alkene over here, and one alkene over here also, which is a closed one. So firstly, when we have seen that how the reactions undergo when we are having a Grubbs second generation. So firstly, it will undergo the ring opening, and after the ring opening thing, it will undergo the ring closing mechanism, but it would happen in intermolecular. So this I would explain in the slides. So here, if I am having a group, please try by yourself also. We are having this N-Bog and one alkene group here. and the other part is N, and this is some other group, NS. So now firstly it will undergo ring opening, and ring opening could only be formed if these twos are having alkenes over here. So it would be like this way, and Bob, and here it is having nitrogen, and NS. Now we have done the ring opening part. Now we have different choices to combine this ring or to combine this ring to give us a product. So what will happen? Whichever the rings are very close, because these two can't combine with each other. We have already opened it, it's a strained one. If you'll just check, this is 1, 2, 3, 4, 5, and 6. This will make a 6-membered ring. Now 1, 2, 3, 4, 5, and 6. I'll just mark it as dash, 3 dash, 4 dash, 5 dash, 6 dash. So this side also it will give you a 6-membered ring. So when you have a 6-membered ring option comparative to the 5-membered ring, always it will go for the most stable ring. So what it will form? So then it would ultimately be forming a 6-membered ring, which is, we'll just take two 6-membered rings, and in the two 6-membered rings, if you'll just carefully see, there is a carbon-carbon bond. So we will just make a carbon-carbon bond, which is 3 dash and 5. Now this 5 is related to the 6, which is combining with 1, then 2, then 3 is nitrogen, which is having NS group. 5 is combined with 4, and this is combined with nitrogen 3. Now 1 and 6 was about to have the alkene. Similarly, other hand, go to 2 dash, then 1 dash. 1 dash is going to combine with your 6 dash, then 5 dash, then 4 dash is your nitrogen. This is your 4 dash, and this is your combination of with nitrogen, and this is having Bob group. And if you will see, 1 dash and 6 dash is going to have double bond, so it is your group. Now, if I'll make it even more properly, so this group is nothing but your nitrogen, nitrogen, double bond, O, this is Bob, and that is NS. So you can easily see that which product that we have formed, and this is matching with our only option number D. Is this clear? If you have any doubt, please let me know, or else we can move further. Okay, great. So this way only, don't get worried just by looking at the substrates, different alkenes. You just have to try out the possible combinations. Best way to give a numbering, and when you have given the numbering, you will be easily able to find out which kind of products without making any mistake. You can just find out the product. Now, let's try this one. The catalyst used in the following transformation. So if you will see carefully, we have an alkene, but this alkene is still bound here. We have an alkyne, and the alkyne is connected to make another alkyne and giving another alkyne. This is your cycloalkyne product. No, not cycloalkyne. So sorry. It's a new alkyne over here. So first alkyne, which is also open, and this is your second alkyne. So this can only be happening when you are taking 2 units of this particular group and they combine together to give you another alkyne and the side product of this alkyne. We have already seen this example that I'm just considering this whole group as R. So if R is here, the other part is CH3, another R I'm taking, which is CH3. Now sorry, this and this would combine and this would combine. So R star triple bond star R plus dotted triple bond, this dot. So now if I'll consider this whole group as R, so this is nothing but my this group and this C and CH3, this is my this group. So here it is nothing but a self metathesis, alkyne metathesis reaction is happening in presence of the catalyst. So what is the question? They're not asking for which type of reaction. You should be knowing in and out of the reaction completely. The question could be made from this particular part. Number of questions could be made. They could ask for what kind of metathesis is being happening, as they have asked for what kind of catalyst is being used. So this kind of metathesis where two alkynes are combining together, we know that happens in presence of metal carbon. We have seen this is your Grubbs catalyst that only gives you the alkene metathesis. Metal carbine is the one which would tend to give you the which would tend to have this kind of self metathesis or cross metathesis of alkynes. The other ones are not the catalysts which are being used for the metal carbene, because metathesis reactions can only be possible when we are having metal carbenes or metal carbines. So these could only be possible, and these are neither the carbenes nor the carbines. So these are anyway eliminated. This option is only for the alkene metathesis, and the right option is your D. I hope this is clear. Now moving to our question number 4. Okay, the question number 4 says that we have this alkene system and this Grubbs catalyst, and it is forming a closing a ring. We can already see that 1, 2, 3, 4, 5, and this part is your 6, and this is giving you this one is your this is 6, this is 1, 2, 3, 4, and 5, and this is your ring closing metathesis. It's very straightforward. Then the substrate of the following reaction is or R. We have the substrate and the alkyne. Now, what would be the substrate which is going to undergo having this reaction? We could only be seeing that this part would be having your different alkynes which are combining together to give you. So if this is having PH and TH and something like this way, or it is having the substrates could be possibly be are this one. So here, this is the only option. If I'm taking these two same groups, that is self metathesis, so the star marks will give you one product, and this CH3 alkyne CH3 would leave as another product. So therefore, the fifth for question number 5, the answer is B. Now the correct statement about the following reaction. We have here alkene groups in presence of the metathesis. Now it is giving you a dimer and a trimer. So this is a tandem ring closing metathesis. Now we already know dimer and trimer concentration is dependent on is dependent on the concentration of the substrate. So yes, A option is right. And if it is independent, no, it's wrong. At higher concentration, the product B, the trimer would be the major product. Yes, if at lower concentration, product A would be the major product, which is absolutely right. So these are the three options which are right, which is A, C, and D. These are the right options. Now we have the seventh question as the substrate of the given reaction. So here, if you'll see again, this is a metal carbene, and we are having a closed ring with a cyclic, with a ethylene molecule out. So this could only be possible if we are having a substrate kind of this way, which is having here methyl, and here it is having there is methyl and there is double bond, and there only you could form. So the option D is your right option, where it is having this particular product where these two combine, and therefore it would form your. If this is the case, then these two have to combine, which is not possible. So the option D is the right option. What is actually happening here? If I'm taking methyl, this methyl, CO2 80. So this dotted and this star mark. So this would be 1, 2, 3, 4, and 5. We'll quickly make the 5-membered ring with a double bond. And here 1 was having, and 1 and 2 are having methyl substituents. 4 is having CO2 ET substituents plus star. It's nothing but the ethylene molecule. So this was been asked and the question 7 is done. Now we have the catalyst of the given reaction. Here again, if you see C6H5, they are combining together to give you this product. If I'm taking this molecule, this also we have discussed, C6H4Me, C6H4Me. So they both will combine together. Sorry, I just made it differently. So if we are having C6H5 triple bond C6H4Me, and similarly other side also the 2 units we are taking, so they would give you a self metathesis product, which is C6H5, C6H5, and C6H4Me. And in presence of what catalyst is happening, so we have already seen it happens in presence of molybdenum catalyst and resorcine in 160 degrees Celsius. So it's an alkyne metathesis. Now the ninth question says the following reaction is an example of. Now here, if you will see, we have an alkyne and ene, and we can see the closing of the ring, and it is having the alkene over here. It is nothing but your ene-ine mechanism, because only then it is possible to have this kind of multi where 1, 2, 3, 4, 5, and 6. So this is your 1, 2, 3, 4, 5, and 6. 3, 2, 1, 5, 4. So the actual things undergo with respect to the mechanism where the metal carbene would undergo with two alkenes would one alkene would undergo the metal carbene and then subsequently it would undergo the alkyne metathesis. So this is iron ring closing metathesis reaction. And the last is the total number of possible products that can be obtained in this metathesis reaction. So we have R1, since it can be possible to give you R1 and R2 can also be giving you R1 and R1, R2 and R2. So both can be having obviously CH2 would be there in every part where one part is going to connect with other one. Since we will be having three different possibilities, these two combine or two molecules of this one combines with this one or R2 combines with R21. So So these are three possibilities which could give you one product, second product, third, and three molecules of this CH2. So possible products would be here six. So with this, we are ending up our live session where we have discussed the questions of certain examples which could help you to solve the assignments. And we have covered ring closing metathesis. We have covered asymmetric ring closing metathesis, then ring opening, ring closing, tandem RCM, and alkyne metathesis, which are very, very important. So with that, I'll end up this session and we will meet in the next class. Thank you so much for joining.